So this is the GCSE Chemistry High 2 paper. It's the OCR 21st Century November 2020 paper. All the information you need to know are on the front here. So we are looking at question 5. Amir is given a solution of potassium sulfate which can be used as a fertilizer. He carries out a flame test on the solution. Describe how Amir does the flame test. So just a quick overview of a flame test. You have a wire loop that's unreactive. You dip it into the sample of the solution that you're testing, and then you put it in front of a blue or colorless flame from a Bunsen burner. Okay, so these are the three things that you need to mention to get these 3 marks. So use a wire or a wire loop, dip the loop in the sample and place it in the flame, and the Bunsen flame should be colorless or blue. Okay, so it can't be the yellow flame. So the flame test is basically used to tell you which specific metal ion is present in the solution. So in potassium sulfate we have potassium present, but obviously the color of the flame tells you which metal is present. So there's various different metals that you need to know about and their flame colors. Okay, and this is what the second part of the question asks you. What color does Amir see when he carries out the flame test on potassium sulfate? So if he places this loop inside this flame, it should go purple or lilac. Okay, so you could say purple, mauve, lilac, violet. So I'll just say purple. Okay, so colors along that range. Part B. Write a balanced symbol equation for the reaction of potassium sulfate solution with barium chloride solution. Show state symbols. So they've given us the reactants, the formula of the reactants as well. So we have potassium sulfate plus barium chloride, and the products produced, we need to find out what they are. So this is actually a double displacement reaction happening. We have 2 ionic compounds. Potassium takes the place of barium, barium takes the place of potassium. So instead of having potassium sulfate, we have barium sulfate produced. This is the formula. Okay, and instead of having barium chloride, we have potassium chloride. Okay, KCl, that's a lowercase l. You also need to show your state symbols. So this is aqueous, it's in solution. Most of them are. This is also aqueous. Barium sulfate, you actually need to know about this one. This is insoluble, so it's a solid. This is also aqueous. I've shown it underneath, but you try to make it so that it's very close to the compound as a subscript. So you've got 1 mark for identifying the products, you get 1 mark for having all of these state symbols, and your final mark is for balancing your symbol equation. So just by looking at it straight away, you know there's 2 chlorine atoms here, but only 1 here. So what I can do is put a 2 in front of there, put a 2 in front of this formula. This 2 applies to everything that comes after it. When balancing equations, you can never put a number after a compound. You always put it in front. So we have 2 potassium now on this side and 2 chlorine atoms. Now looking back at this side, it's now balanced. We have 2 potassium here and 2 chlorine atoms here. So in the original formula you can have a 2 after it, but when you're balancing it you can't change the original formula. You have to put numbers in front if you want to change the numbers of atoms, and that would give you your 3rd mark. Now it's balanced. A final thing I also wanted to mention is how do you know what the formula of the compound is. So that's to do with the charges of the different compounds. So SO4 has a 2- charge. Barium is in group 2, it has a 2+ charge, so these charges balanced. Okay, so you need to have your charges balanced in the formula for you to have the correct formula. Same here, so ignore this 2, potassium and chlorine. Potassium has a +1 charge, chlorine is in group 7, it has -1 charge. Therefore you only need 1 of each atom in the formula to have a balanced charge. Okay, so that's why we have KCl instead of KCl2 like here. Okay, we don't have Cl2 like that because these charges are now balanced. Looking at this one, barium again is in group 2, it's got 2+ charge. Chlorine is in group 7, it's got -1 charge, but because we've got 2 of those, you have -2. So that's why you have 2 Cl. It's to do with the charges and balancing those charges. Okay, next question. Amir has a sample of another fertilizer, fertilizer E. He looks at the emission spectra of fertilizer E and potassium sulfate. So we've got the emission spectra, which shows the different wavelengths of light, and we've got emission spectra for potassium sulfate. So emission spectra, just like the light given out by those compounds, that light can be measured by a spectroscope and it gives out a emission spectra. So that detects different wavelengths of light, okay, and different metal compounds that are in a sample give out emission spectra of lines at different points, okay, because they have different wavelengths of light. So potassium sulfate has potassium in there, so this is wavelengths of light given out by potassium. We've got one near 400, another one here, and the last one there. So the question is, what can I conclude about fertilizer E from these emission spectra? So all the lines that are in potassium are also in fertilizer E, but fertilizer E has additional lines. So what you can say is the metal potassium is present in fertilizer E, okay, alongside other metals, because look, you've got two lines here that could be for another metal. Compounds can be analyzed using a flame test or an emission spectra. State one advantage of using an emission spectrum to analyze compounds. So this question is asking you, making you compare manual methods with automated methods. The result is more accurate. Okay, so more accurate result. You get the result faster. It's more sensitive. You don't have to judge which color, because different people can judge the colors differently. So there's no room for human error. You don't need to judge the colors because it just gives you the specific wavelengths of light. So I'm just going to say it's more accurate. That's one of the things you could mention.